Hi everyone, it's Miss Dunn. I'm here with you today to explore and take a look at cliffs and caves. So we're going to explore this activity called Cliffs and Caves by using this interactive simulator that's linked in our image to the right. And you just need to click on it and you will be able to go to the link for that activity. I've already got it open, so I'm just going to change up my window so that we can see the activity that we're going to be working with. And I got to move my webcam a little bit. I'm going to slide it back into that position shortly. So we're going to use this activity to complete the slides that follow. And because sometimes it is hard to juggle multiple windows, and because it's hard to, bounce between multiple tabs, it might be helpful for you to have some paper, blank paper preferably, and something to write with. It's an option. You don't have to do it, but it'll probably help if you write your answers on paper first. We're going to move to the next slide. So here we are, and we're presented with this table. And we need to use the numbers in the table to model scenarios in our little mountain climber simulator. So what I notice when I look at this simulator is that I have a starting elevation slider, right? That's this top slider here. I can move it and I can see my little mountain climber go up and down. And I notice that the first column of my table is starting elevation. So the number in the first column of our table is going to determine our starting elevation. So it looks to me like that's 200. I'm going to type in 200. The second column of my table is change in elevation. And if I look at my simulator, I see that I have this second slider here that is elevation change. And again, I can slide it back and forth, watch my little mountain climber go up and down. But I notice that in this first row, my change in elevation is 70. It's a positive 70. So I'm going to set my change in elevation for positive 70. And now I can see that having put in that starting elevation and that change in elevation, my mountain climber is sitting way up here at the tippy top of this mountain. And it's our job to figure out what is that final elevation that he's at. What is the sum of the starting elevation and the change in elevation? Well, couple ways, couple cues I can use to figure that out. The first would be to drop your mouse next to your mountain climber and trace it on over to our y-axis and see where that lines up on the y-axis. That's one cue you can use. You'll also notice that we have these arrows, much like we had in our opening activity, these arrows modeling our starting elevation and our change in elevation. And likewise, if I go to the very end of those arrows and I follow them over to the y-axis, I can figure out what the elevation is. Now, I do notice that this particular line that it looks like my mountain climber is hanging out at, there's no number on it. But I can use the number above it and the number below it to figure out what this middle number is, because I know that the scale on a graph always has to be constant. So every little line has to be worth the same amount. So I see that I have 260 right below my little line. I have to go some amount to my next line, and then I have to go an equal amount to reach 280. So really the question I can ask myself is, what's halfway between 260 and 280? Or I can ask myself, what would I skip count by to get to 280? So I know, because I'm super smart, y'all, that if I count by tens, I can go 260, 270, 280. If I keep counting by tens, I get 290, 300. So it looks like the scale on this graph is going by tens, which means that my mountain climber is sitting here at 270 feet. So that's what I would then type into my table. And let me try to show you that. I'd go in, I'd type in 270, and that's how I find the final elevation. You're going to use this simulator for a number of slides in here, so get comfortable with it and start modeling.